Hello. Good afternoon, everyone. Good afternoon to each and every student. How are you all? Is everything good? Hope you are doing well and hope you are studying also with a constrained time limit. You are taking good sleep also because it is necessary at that time. Okay. So with that, we'll start today's discussion. Actually, in last class we had some connection issue. So due to that, we were not able to discuss the paper. Right now, today we'll discuss the paper, and in the next classes we'll cover the remaining portion. Okay. So with that, we'll start today's first question. So let's read. Okay. So first question is saying that set A is given. Okay, and set B is also given, and then we have to find the number of elements in the set C, which is subset of A. Okay, so whatever C we will define, it should contain either complete set A or some element of set A. Clear? For example, let's say I can take no element, or I can take one element. Let's say one. I can also take, let's say, one element like this, 9, right? Or I can take two elements, or I can take three elements, let's say 3, 5, 7. Okay, in that way, I can take all the elements, means I can also take complete set A. Okay, these are the subsets. So how many total number of subsets we can find out? All those subset will be actually forming a set, right? Clear or not? Subset is also a set. Clear? So in that way, we can form a set C, which is a subset of A. So if you remember, if n of A here is 9. So if you remember, I told you in the previous classes, or you must have learned that if any set have n number of elements, or let's say p number of elements, then the number of subset in that set would be 2 to the power p, right? So here, if I talk about n of number of subset of A, number of subsets, then that will be 2 to the power 9. Clear? Now we have to, one condition or also is given here, that C intersection B should not be a null set. Not equal to 5 means not equal to null set. So what we do, instead of finding non-null set, we'll find the number of null set and we'll subtract from all the number of sets. Okay, we already found how many subsets will be there, 2 to the power 9. So in these ways, I can form set C. So C will be the total number of sets which I can form using subset of A. Okay, now in those total cases, what I'll do, we can remove the number of null sets with set B. So it is saying that what we'll do, total minus null set of C and B. C and B means C intersection B. So total number of subsets we have found 2 to the power 9 minus number of null set with C and B. So here we have I have given you some of the examples, right? So what we can do here, in those examples, some sets would be like this. Here C intersection is not a null set.
पानी कैसे आ रहा है?
Amit, can you mute yourself? Okay, so here what we can do, we'll find C intersection B is a null set. Okay, so if I'll take, let's say, this set C, so now you can see here C and B does have some common elements. Intersection means common elements. So here you can see 5 is common. Only 5 is common. So C intersection B will not be a null set. So what is the thinking? Thinking is we have to take C such that the common element with B should be no element. There should be no element with B set. Okay. So what we do, we will remove all those elements which is common to A, because eventually what we are doing, we are taking elements from A and then we are intersecting B, and it should be a null set. So we'll remove all the common elements. So if I'll remove common elements are here 2, 5 and 8, if you see. So I'll remove 2, 5 and 8. So now how many elements I can take from sets A? Remaining 6 elements, because total 9 elements were there and I have removed 3. So total 6 elements remain. And out of these 6 elements, how many subsets I can form? See, in these 6 elements would be 1, 2, sorry, not 2, 1, 3, 4, 6, 7, 9. These are the 6 elements. Let's say I'll choose only one element, 1, or I can choose 1 or 3. Now you can see all these set B, if I'll take intersection with set B, it will be a null set. So it is satisfying this condition. But the thing is, here we are getting more number of answer, not only one single set. So what we'll do, we can choose any number of elements out of these 6 elements. Either I can choose 0 element or 1 element or 2 elements and so on up to 6 elements. That means what we are doing, we are eventually finding the number of subset from this set. Okay, so here you can see, let's say if I'll assume this is, okay, so this will be my final C. B is also is not is a null set. Sorry, it is a null set. Okay, so here number of NC is here is, let's say I'll take not C, I'll take it as P set. So NP is here 6. So number of subset of P, number of subsets of P will be what? 2 to the power 6. So I'll remove these number of sets from the total answer. So this will be my final answer. So we can calculate 2 to the power 9 is 512 minus 2 to the power 6 is 64. If you calculate, you will get around 512. So 52. 52 means 448. 448 would be my answer. Option number C is correct. Clear? I hope you have understood this idea. What is the main thing here we have done? We have found the total number of ways and we have removed all those cases where C intersection B is a null set. Means basically we have used contradiction method, right, which we have generally used in PNC type of problems. Okay, so now we'll move on to the next question. So next question is this. Here Z is a C. Z belongs to C means C is a complex number. C is a complex number, and we have to find the minimum value of this modulus plus this modulus. Okay, so okay, we don't have to find. Actually, it is given the minimum value of modulus of this function, this value plus modulus of this complex number is 5√3. So why don't we assume these two complex numbers as Z1 and Z2? So if I'll assume let Z1 be 4 minus, sorry, Z minus 4√3 wait a minute. Okay, so I have assumed Z1 as Z minus 4 root 3, and I can assume Z2 as another complex number which is given Z minus K root 3 iota. Okay, so these two complex number, if I assume, so my final condition would be we have to find the minimum value of Z1, modulus of Z1 plus modulus of Z2. This minimum value is given to us as 5 root 3. So whenever two modulus functions are given and we have to find minimum or maximum, clearly in our mind it should strike as triangle inequality. Okay, so this is basically a triangle inequality question where we have to use that sum of two sides is always lesser than the third side, right? Or difference of two sides is always greater than the third side. So here you can see a plus sign is there. That means sum of two side will be greater than the third side. Okay, so third side, how we can form? Let's say if I'll draw, if I'll tell you the basic concept of this, then I let's say here on this argent plane, this is imaginary axis and this is real axis. So if I assume on an argent plane, let's say this point is Z1 and this point to be Z2. Okay, so modulus of Z1 means distance from origin. Point of Z1, distance from origin. So this will be my Z1, modulus of Z1. Similarly, Z2 will be distance of Z2 from origin. So this will be modulus of Z2. Okay, and so to form modulus of Z1 plus Z2, we need to use parallelogram of parallelogram addition of law. Okay, so what we do, we'll draw parallelogram. So I'll draw another line segment which is equal to modulus of Z2, and from Z2 I'll draw another parallel line segment which is whose length is mod Z1. So now you can see this net length will be modulus of Z1 plus modulus of Z2, right? So and also if we try to write it, what we can do, we can see that sum of two sides is always greater than the third side. Okay, so actually this is one side. Okay, so this should be greater than the third side. Sorry, we can say that modulus of Z1 plus modulus of Z2 is always, let's say Z1 to be one side, modulus of Z1 to be one side, modulus of Z2 be to second side. Then this is the sum of two sides. Sum of two sides. Clear? So one side and second side. So this would be greater than the third side. So this would be greater than or is equals to the third side. So Z1, modulus of Z1 plus Z2. This I should write modulus of Z1 plus Z2. Clear? So, but also if I try to write this side, then what we will write using using the triangle law. So I can say if this is Z1, this is Z2, then this will be Z2 minus Z1. So again, now I can say from this triangle, sum of these two sides is always greater than this side. Okay, so also I can write also modulus of Z1 plus modulus of Z2 is also greater than minus Z1. Okay, so I can use either of them. But the thing is, if I'll try to add them, there will be 2Z and I don't want Z, right? So to remove Z, what I need to do, I need to subtract them. So Z2 minus Z1 I should use. So here we can write Z1 plus modulus of Z1 plus modulus of Z2 minimum value. Minimum value will be achievable when this value is equals to right hand side. So minimum value will be Z2 minus Z1. So if I'll do Z2 minus Z1, I'll write z minus k root 3 iota minus z plus 4 root 3. Right? This will be my minimum value, and which is eventually equal to 5 root 3. So finally, what we will do, we can cancel z and minus z. So inside the modulus sign, I can write 4 root 3 minus k root 3 iota modulus is equals to 5 root 3. Now, clearly this is a complex number, and modulus of complex number is what? Root over a square plus b square. If z can be written in terms of a plus iy. So here a is 4 root 3 and b is minus k root 3. So first of all, we can also take root 3 common. So if I'll take root 3 common, root 3 will be cancelled out. Now I can take a square plus b square. So a square means 16 plus minus k whole square means k square whole under root is equals to 5. Okay. So now in the next page, what we can do? We can square both sides. So squaring plus k square is equals to 5 square means 25. So here we got k square is equals to 9 or k is equals to plus or minus 3. Clear? Now we will check which option is correct. We have to find the value of k. So k will be 3. And here minus 3 is not given. So only one option is correct. Clear? Also, you can see that it is only asking a value of k. Clear? So it is also giving us hint that only he's interested only one value of k, which is in the option which is 3. Okay. So basic concept is what? Triangle inequality. Triangle inequality means sum of two sides is always greater than the third side, or difference of two sides is always lesser than the third side. Clear? Now we'll move on to the next question, 63. So now you can see this is basically binomial theorem question. Okay. And binomial theorem also, here you can see it is asking for the coefficient of x to the power 6, y to the power 4 in the expansion of this. So now you can see this is a trinomial. Trinomial means in binomial generally we have learnt about two terms. We have two terms. Two terms means binomial theorem we have learned expansion of two terms, right? But here three terms are there. So for three terms or more than three terms, there is one concept in binomial theorem which is multinomial theorem, right? So we have learned a concept in multinomial theorem such that if a plus b plus c to the power n, some expansion is there, and we have to find the coefficient of a to the power k1, b to the power k2, c to the power k3. Then the concept is the coefficient will be n factorial upon k1 factorial, k2 factorial, k3 factorial into a to the power k1, b to the power k2, c to the power k3, and also k1 plus k2 plus k3 should be is equals to the power which is n. Okay, so we are going to use this concept. So here in this question, the expansion is x plus 2y plus 3xy to the whole power 9, and we have to find the coefficient of x to the power 6 into y to the power 4. Okay. Now here the thing is, at the first time at the first instinct we can see that here the power sum, I have told you that if power is asked k1 plus k2 plus k3, then it should be is equals to n, but here 6 plus 4 is not equal to 9. Okay, so the thing is here we have three terms, and where there are x common. So it might be possible that there is some power k1, there is some power k2, and there is some power k3, such that now in the net power of x, it will be k1 plus k3. Similarly, the net power of y will be k2 plus k3. So the coefficient, we'll use the same formula. We'll write down here n is 9. So 9 factorial upon k1 factorial, k2 factorial, k3 factorial into terms. What is first term? First term is x. So x to the power k1 into second term is 2y. So 2y to the power k2 and 3xy to the power k3. Okay, clear? What we need to find out? We need to find out the coefficient of x to the power 6 into y to the power 4. So first of all, we should rewrite it and such that x to the power something and y to the power something is there, so that we can equate with this. Okay, so here we can write it down k1 factorial, k2 factorial, k3 factorial into. Now from here we can see 2 to the power k2 is out, and also here 3 to the power k3 is out. Okay, so this will be my net coefficient, and remaining thing is x to the power k1. Here also x to the power k3 will be there. So k1 plus k3 will be the net power of x. Similarly, y to the power will be k2 plus k3. Right or not? So now we can compare. We need to find out x to the power 6. So it means this value should be is equals to 6, and y to the power k2 plus k3 should be is equals to 4. Also the important thing is sum of all the powers means k1 plus k2 plus k3. Remember, we have used k1, k2 and k3. So this sum should be also equal to the net power in the binomial expression. So that is 9. Okay. Now, using the comparison, we can say that k1 plus k3, the x power should be is equals to 6, and k2 plus k3 power of y should be is equals to 4. So three variables are there. We can easily solve. Okay, so what we'll do, let's say this is equation number 1, 2, and this is 3. So if I'll add these two, and from these two, by adding these two and I'll subtract this equation, then we can get k3, because here k3 is 2 times. So if I'll add these, LHS will get k1 plus k2 plus 2k3. And if that net equation, if I'll subtract this equation, then k1 and k2 will be subtract. Only k3 will be remain. So I'll solve in the next page. So what I'm doing, I'm adding equation number 2 and 3 and then subtracting 1. So k2 plus k3 on the LHS side of equation 2 is this. Similarly, on the LHS of equation 3 is, you can see k2 plus k3. Sorry, here it is k1. It is k1. So k1 plus k3. On the left hand side, here again k2 plus k3. And then in the first equation, it is all, means minus times k1 plus k2 plus k3 is equals to, on the right hand side, what we will write? On the right hand side, we'll write 6 plus 4 minus 9. So 6 plus 4 minus 9. Now you can see 1 k1 cancelled, k2 cancelled, 1 k3 cancelled. Only remaining on the left hand side is k3. On the right hand side, 10 minus 9 is 1. So we got k3. Now we can use this k3 in any of these two equations, either second or either third, to find the remaining variables. So from 2, if I'll put k3, I will be getting k2. K2 will be 6 minus 1, which is 5. Similarly, from 3, we can find k3. So k3 will be 4 minus 1, which is 3. So ultimately, we have found all the variables k1, k2, and k3. So we have to find the coefficient. So coefficient is this. So we'll substitute the k1, k2, k3 values. So coefficient will be 9 factorial upon k1 factorial. K1 factorial is, okay, this is 1. Let me check again. No, this is 2 and this is 1. Okay. So k1 factorial is 5 factorial. I'll write it again, k2. Okay, and k3 factorial is 1 factorial into 2 to the power k2. 2 to the power k2 is 3 into 3 to the power k3, 3 to the power 1. So we can solve this. So 9 factorial I can write 9 into 8 into 7 into 6 into 5 factorial. Why I am writing 5 factorial? Because in the denominator 5 factorial is also there, so it can get cancelled. So 2 power 3 is 8 and into 3. So this is basically 6. So 6 2s are, sorry, 3 2s are 6. 5 factorial cancelled. And I can also cancel 2 4s are 8. So what I'm getting, 9 8 is 72. 72 into, let me check what are the options are given. Okay, so coefficient is given k into 2 to the power 6 into 3 to the power 3. So what I'll do, I'll equate it 2 to the power 6 into 3 to the power 3, which is equal to 9 into 8 into 7 into 6. What I'm doing, I'm writing in terms of only 2 to the power 6, 2 to the power 3 here, and here it is 3. Okay, and it is 3 factorial. So 5 factorial is cancelled. Now, okay, we can cancel this also. So this is 2 and this is 2 square. Okay, now here we'll get this 8 is 2 to the power 3. 9 is what? 3 square. Okay, 7 is there, so we'll write 7 only. So into, from here this is 2 into 3, so 1 2 to the power 1 is there, so 3 plus 1 4 plus 2 6 into 3 to the power 2, and here it is power 1, so 3 cube into remaining is 7, right? So 2 to the power 6 and 3 to the power 3 is cancelled out. Finally, we are getting k is equals to 7. So let's see which option is correct. K is equals to 7. B option is correct option. Clear? Basic thing is, using multinomial theorem, we have to find it, the coefficient. So we'll compare the x to the power 6 and y to the power 4 from the formula. Clear? This was an easy question if you remember the multinomial theorem formula. Next question is 64. So here what we need to find, we need to find sum of this term plus this term plus this term and so on. Okay, so what at the instant it can be seen that this is a sequence series formula, right? A sequence series question. Okay, so what we do, plus means summation. So actually it is given summation of, not like that summation. If you see in the first term in the denominator, that is 15 minus k. Okay, and second term is 30 minus k. Here I am talking about first number in the denominator of each term. So here it is 45 minus k. So what is happening? This is 15 into 2 I can write. This is 15 into 3. Okay, likewise I can write it down. Okay, so in the first term, if I try to generalize it, what I can write 15 n minus k. Okay, summation of from n is equals to 1. So if I'll put n is equals to 1, I'll getting same thing. Okay, at the last, what is we are getting 300. So we have to check 15 times what is 300. So 15 times 20 is 300. So it means the last term should be is equals to 20. So summation will be from 1 to 20. Now next term we have to think. So here it is 30 minus k. Now what is happening? Now I cannot write in terms of multiplication because 30 and 45 cannot be write in terms of multiplication, but I can see that each time 15 is added. Okay. Also, if I compare second term with the first term, we can also see that each time 15 is added. See, 30 plus 15 is 45. 45 plus 15 is 60. 285 plus 15 is 330. So ultimately what I am doing to getting this, what we are doing, we are adding 15 here. So 15n plus 15 minus k. I can write it down this one. 15n plus 15 minus k. Now using partial fraction or solving, if you remember, how do we solve the product of two numbers in the denominator? We will try to write numerator in terms of subtraction of these two. So you can see this term, this is, let's say, second term, this is first term. So second minus first is actually is 15. Okay, so what I'll do, I'll multiply the numerator and the denominator by 15. Now I can write 15n minus k into 15n plus 15 minus k. Okay, now this 15 can be written off as this minus this. So I can write 1 by 15 sigma 15n plus 15 minus k minus times 15n minus k. So now you can see in the denominator it is nothing but 15 only. Now I can separate the numerator. Sorry, separate the denominator. So if I'll separate this part, you can see 15n plus 15 minus k is cancelled. So I will write 1 by 15, then bracket summation of 1 upon 15n minus k minus summation of, now in the second part this is cancelled, 15n minus k. So 1 upon 15n plus 15 minus k is remaining. And what we have to do, sigma is varying from n equal to 1 to 20. Okay, so we'll substitute 1 by 1. So 1 by 15, if I'll put n is equals to 1, I'll get 15 plus k, 15 minus k minus 1 upon 15 plus 15, 30 minus k. Then plus, if I'll put n is equals to 2, we'll getting 30. So 1 upon 30 minus k minus 1 upon n is equals to 2. 30 plus 15, 45 minus k, and so on. At the last, what I'll be getting, 1 upon 300. The same thing, 300 minus k minus 1 upon 315 minus k. So now you can see that this cancellation is done. Okay, this is called telescopic cancellation. Means all the terms in the diagonal from right hand side will be cancelled out. So only this term, first term and the last term is remaining. So we can now solve these two. So what we can write now, we can write 1 by 15, 1 upon 15 minus k minus 1 upon 315 minus k. Okay, this is equal to 150, 1 upon 155. So 1 by 155. So 15 I can cancel out from 5. 5 31s are 55 and 5 3s are 15. Now I can take LCM. So 1 by 3 I can take cross multiply. So here I will write, if I'll take LCM, 315 minus k minus this. So only 315 minus 15 is remaining upon multiplication of the denominator is equals to 3 upon 31. This is basically 300, and 300 is cancelled with 300 by 100 times. Now again cross multiply. So 3100 is basically equal to 15 minus k into 315 minus k. Okay, what we need to find out in the question, it is asking the maximum value of k. So there, this is clearly a quadratic equation. So two values of k will be coming out. So we have to solve this. So I am solving right hand side, multiplying basically. So k square, then minus 315k and minus 15k will be minus 330k plus 15 into 315. So we have to do calculation into 15. So this is 1575 and 315. We have to add. So we'll be getting 7 and 4. 414725 is equals to 3100. So we'll be getting k square minus 330k plus, if I subtract 3100, we'll be getting 1625. Now we can solve easily using Dharacharya method, right? Or Baba method, we can say. So we'll be getting, basically we'll be getting k is equals to 330 plus minus b square. So 33 into 33 we have to do. So basically means 30 plus 3 whole square. So it will be 900 plus 9 plus 19 to 180. So 1089. Okay, so 108900 because 330 minus 4 into this. So 16 fours are 64, 64 and 100, 6500 upon 2. So finally, if you'll solve, you will get two values of k. So basically, whatever is the maximum value you are getting will be your final answer. I am leaving at that point. You can solve it and find the answer. Clear? Easy, right? So basically, we have to do. We have to generalize the term, and then we have to use partial fraction or telescopic method to cancel out, so that each diagonal term will be cancelled out and we'll be getting the final answer and equating it with 1 by 155. Okay. Next question. Next question is question number 65. So here in this question, it is saying that L1 be a straight line passing through origin and L2 be a line x plus y is equals to 1. Okay, L1 is passing through origin. That clearly means L1 can be written in terms of y is equals to mx only, because c will be 0. So I can write L1 as y is equals to mx. Okay, L2 is given. L2 is x plus y is equals to 1. Now, if the intercept made by circle, this circle is given, so we can find the center as well as radius. So center is actually half of the minus times half of the coefficient of x and half minus times half of the coefficient of y. So here coefficient of x is -1. So we have to multiply with minus half. So center of circle will be 1 by 2 and minus 3 by 2. Also, you can see that here the constant term is 0. That clearly means that circle is passing through origin also. So it is passing through 0, 0. This line is also passing through 0, 0. And intercept made by these two lines on this circle. We can find the radius also. Radius is root over g square plus f square minus c. So g square is 1 by 4 plus 9 by 4. C is 0. So 10 by 4 means 5 by 2. So root 5 upon 2 is the radius. Okay. So some circle is there. Okay. One line is there, L1. Another line is there, L2. This is L2. This is L1. And the circle is making equal intercept. Equal intercept means this length AB and this length CD will be equal. AB is equals to CD. So that means AB and CD are both acting as chords of this circle. So if two chords are equal, then the distance from center to these chords are also equal, right? So we can also say that perpendicular distance from center to both the chords, let's say center is C, not C, let's say I'll take another point, P. So center is, let's say, P. We know the radius. Radius is root 5 upon 2. So this will be also root 5 upon 2, right? Okay, we also know that if AB is equals to CD, then you can see this is a right angle triangle. Okay, wait a minute, I have done mistake slightly. This is not R. Actually, R is this one. CP and BC. BP. These are both radius R. Okay, so this is a right angle triangle. We know that if we drop a perpendicular to a chord, then it will bisect. So CD is equal, CM is equals to MD, and AN is equals to BN. These two are also equal, means all these four will be equal, right? So let's say this chord length is X, then this length will be X by 2, right? This will also be X by 2. Clear? Now, and this is also be X by 2. So what we can do, using Pythagoras theorem in both the triangles, we can find out this length, and we know these two lengths will also be equal. So what we will do, we can write Pn is equals to Pm. That means perpendicular distance. So using Pythagoras theorem, we can write R square minus, okay, so line equation is given actually. L1 is x plus y is equals to 1, and L2 is y formula from one point. Okay, so we don't have to do this much also. What we can do, we can find perpendicular distance from a point. P is given 1 by 2 comma, I'll remove this whole graph and write it again. This is one circle. Okay, there is one line, another line, both are making equal intercept. This is L1, whose equation is x plus y is equals to mx, or mx minus y is equals to 0. Second equation is x plus y is equals to 1 for line L2, and the circle center is 1 by 2 comma minus 3 by 2. Radius is also given. Okay, so what we do, we'll find out the perpendicular distance. So we know from a point, the distance formula is, if a line is ax plus by plus c is equals to 0 and point is x1 comma y1, then perpendicular distance is ax1 plus by1 plus c modulus upon root over a square plus b square. So d will be here ax1 plus by1 plus c whole modulus divided by root over a square plus b square. So I'm going to use this. Okay, so from P to L2, what will be the perpendicular line? That will be 1 by 2. I'll put the point center on the line. So 1 by 2 minus 3 by 2 minus 1 whole modulus of coefficients square. So 1 square plus 1. From point P to this line. So we'll be right m into 1 by 2 minus y into y is minus 3 by 2 whole divided by root over m square coefficient of x whole square plus y square. Okay, both distance will be equal, right? Because if chord length is equal, then perpendicular distance from center is also be equal. So we can write 1 by 2 minus 3 by 2 is minus 1 minus 1 minus 1 is minus 2. So minus 2 modulus is 2 by root 2 is equals to, here we can take 2 common, 1 by 2 common. So 1 by 2 is outside. We'll rewrite modulus of m plus 3 upon root over m square plus 1. Okay, so this 2 I can write it here. This is actually root 2. So this will be 2 root 2, and then we'll completely cross multiply and then whole square, because root is there. So 2 root 2 into root over m square plus 1 is equal to modulus of m plus 3. Clear? So now we'll square both sides. If we'll square on both sides, we'll be getting 2 root 2 square is 8 into m square plus 1 is equals to m plus 3 whole square. Okay, now here it is 8m square, here it is m square. So I'll be taking all the variables on one side. So 7m square. Then plus 6m will be there. So I am taking on the left hand side. So minus 6m. Then plus 8. And here it is plus 9. So 8 minus 9 will be minus 1. So this is the final quadratic I am getting. So now what we'll do, we'll solve this. So the equation is, I'm writing it again, 7m square minus 6m minus 1 equal to 0. Or here we'll be get 7m square minus 7m plus m minus 1 equal to 0. So finally we'll be getting m is equals to 1 comma minus 1 by 7. Okay, so we are getting two values of m, means accordingly we'll be getting equation of L1 as two lines. One is for m is equals to 1 and other is for m is equals to minus 1 by 7. Okay, so we have to put both. So for m is equals to 1, L1 will be x, y is equals to mx, right? So basically y is equals to x, or we can write x minus y or y minus x equal to 0. And for m is equals to minus 1 by 7, we will be writing L1 as y is equals to minus x upon 7, or x plus 7y is equals to 0. So we have to check which option is correct. So x plus y, no. X minus y, no. So both options are wrong. Now second one, we have to check x plus 7y equal to 0. So x plus 7y is option number C is correct. Clear? So what is the basic funda? Basic funda means if a circle is there and two lines are intercepting the same intercept, okay, making the same intercept, then perpendicular distance from center will also be equal. And we know the perpendicular formula from a point to a line. That is the formula. D is equals to modulus of root ax1 plus by1 plus c upon root over a square plus b square. Okay, moving on to the next question. 66. 66 is saying if a chord of contact of pair of tangent from a point P on this. Now clearly this is a ellipse. Okay. So there is a point P on this ellipse. So what we can do, we can use parametric form. Okay. So here this ellipse can be written x square by a square plus y square by b square is equals to 1. Clear? So the parametric point P will be 3 cos theta comma 4 sin theta. A cos theta comma b sin theta, right? So chord of contact of pair of tangent from a point P. So ellipse is actually a vertical ellipse because here A is 3 and B is 4. So clearly A is less than B. So it will be a vertical ellipse. So we'll draw vertical ellipse. Okay. These endpoints are 3, 0, a, 0 and minus a, 0, right? And these are 0, b. So 0, 4 and 0, minus 4. Okay. This equation, let's say this is even. So this is even equation. Even curve is there. Now there is point P from chord of contact of pair of tangent from a point P on this to the ellipse. Okay. So some point is there. Let's say P point is there. And from this P point, pair of tangents is drawn to the ellipse, this one. Okay. Now E2, I'll assume this as E2. So x square by root 3 square plus y square by 2 square is equals to 1. Again, this is here a is root 3 and b is 2. So clearly again a is less than b, means this is again a vertical parabola, vertical ellipse. Okay. So what is saying that pair of tangents from this point P is drawn. Okay. The chord of contact of pair of tangents. Okay, so what is chord of contact? If if a pair of tangents is drawn, then whatever is the point of contact, we'll draw those point and it will be a chord of contact. So we'll draw another, or why don't we draw in this? Okay, so root 3 will be inside here and 2 will be somewhat here. So this is 0 comma 2. So one vertical ellipse I'm drawing like this. Okay, so this will be my another ellipse E2. So from P we have drawn two tangents and these two tangents making a chord of contact. So this will be my chord of contact, somewhat like this. Okay, is normal to this coefficient of x square and y square is same, means this is actually a circle equation. So we can write this circle as x by dividing by 2, x square plus y square minus 2x minus 2y plus half is equals to 0. Okay, so what it is saying that this chord of contact is actually normal on this curve. That means this chord of contact, normal is what? If a normal is always passing through the center of the circle, right? So we'll find out the center. Center here is 1 comma 1, right? So it means that chord of contact will be passing from 1 comma 1. That means normal, we know that normal always pass through center of circle. That means chord of contact will satisfy 1 comma 1. Center is 1 comma 1. So basically we have to find chord of contact. So we know that how to find chord of contact if this point is 3 cos theta comma 4 sin theta. Equation of E2 is also given. E2 is given x square by 3 plus y square by 4, or this equation, right? So we know that chord of contact is actually x1 is here, it is treating as x1 and this is treating as x2. If sorry, y1. So if x1 comma y1 is the point, then chord of contact is xx1 upon a square plus y by 1 upon b square is equals to 1. So x into 3 cos theta by 3 plus y into 4 sin theta by 4 is equals to 1. This is my CC. CC means chord of contact. And this is passing through 1 comma 1 means center of the circle. So it will satisfy 1 comma 1. So satisfy 1 comma 1, what we will do? 3 cos 3 and 3 is cancelled. 4 and 4 is cancelled. So we are getting cos theta plus sin theta is equals to 1. Cos theta plus sin theta is equals to 1. What does that mean? We can write it as cos theta is equals to 1 minus sin theta, or now we can whole square. So we'll be getting cos square theta. Okay, instead of that we can write this a sin theta plus b cos theta form. So we can write root over a square plus b square sin theta plus pi by 4 is equals to 1. Okay, so here we'll be getting sin theta plus pi by 4 is equals to 1 by root 2, or theta plus pi by 4. I think just a minute. Just a minute, guys. Okay, so here we are getting, now this is sine pi by 4. So we can write either pi by 4, also we can also write pi minus pi by 4, because sine is also positive in second quadrant. So we'll be getting theta is equals to either 0 or 3 pi by 4 minus pi by 4 is pi by 2. So now we have to check eccentric angle of point P. Eccentric angle is actually theta. So we have to find theta value. So theta value is pi by 2. Only one option is there. So option C is correct. Clear? Funda is clear. What we need to do, we have to take, then we have to form a chord of contact. So for any point x1 comma y1, let's say, if there is chord of contact on any curve, then on that curve what we do, we'll replace x square by xx1, y square by y by 1, and x as x plus x1, y, sorry, 2x as x plus x1, 2y as y plus y1, and constant term remains same. Okay, so that's how we got this chord of contact. Then we know that chord of contact is actually normal to the circle. So that means normal is actually passing through the center. So this chord of contact will also be passing through the center. And center we have found 1 comma 1. So we have satisfied with 1 comma 1 and find out our value of theta, which is the eccentric angle of point P. Clear? So now we'll be solving next question. Next question is, tangents are drawn from point alpha comma 2 to different branches of hyperbola. So first of all, we need to simplify this hyperbola and write in the standard form. So here I'll write down x square terms, club them x square, x terms and y terms. So x square minus 2x, I'll clubbing them, then minus 4y square. So what I'm doing, minus 4 I am taking common, because 16y also 4 is common. So y square plus 4y, and remaining is minus 31 is equals to 0. Okay, now you can see, to make it perfect square, I have to add 1 here. If I have added 1, I have to subtract 1 also. Similarly here, to make it perfect square, I have to add 4 and subtract 4. Okay, so it will be x minus 1 whole square, then minus 1 is there, minus, this is 2 square, so 2 times, and this is y plus 2 whole square, y plus 2 whole square. So actually I'm writing in that way, 2 into y plus 2 whole square. Now minus 4 into minus 4 will become plus 16, minus 31 is 0. So finally we are getting x minus 1 whole square minus 2 into y minus y plus 2 whole square, and here we are getting minus 1 plus 16 is plus 15 plus 15. Okay, we can solve this one. This is minus 15 and minus 1 minus 16 is equals to 0. So finally we are getting x minus 1 whole square. 16 I can, minus 16 I can transpose to the right hand side and divide the whole equation by 16. So I'll write 4 square. Then this is 4 actually. So I am taking y plus 2 whole square. 4 upon 16. 16 will be 4. So it will be 2 square is equals to 1. So now this is converted into standard form. Clear? So this is clearly a hyperbola. X upon a whole square plus minus y upon y square upon b square is equals to 1. Clear? So here you can see that the center will be 1 comma minus 2. A is 4, B is 2. So clearly A is greater than B. Okay, one thing. Now what we need to do? We need to, so this is clearly a hyperbola with, now tangents are drawn from a point alpha comma 2. Okay, so first of all, we'll draw a hyperbola whose center is 1 comma minus 2. So this is my coordinates. Then 1 and a minus 2 will be somewhat here. This is my center, 1 comma minus 2. And from this, I'll be drawing a, means considering this as center, I'll be drawing a hyperbola. Okay, so hyperbola will be somewhat like this. Right? Or like this. Clear? Now, alpha comma 2. If I'll try to think this point, from this point we have to draw tangent to both the branches. So alpha comma 2 means here you can see this y coordinate is fixed, which is 2. So I can think of it as a point lying on y is equals to 2. So y is equals to 2 means somewhat here. This is my y is equals to 2. On this line, there is a point alpha comma 2. So let's say I am drawing it here. Assuming this is point P whose coordinate is alpha comma 2. Now we have to draw tangents. So let's say one tangent is somewhat like this. Okay. And another tangent is somewhat like this. Clear? Or more specifically, I can draw like this two tangents on different branches. Okay. Now we have to find now what is the range of alpha. Okay. So to this point, from this point, if I'll draw tangents, then I can see I can find the asymptote of these hyperbola. So we know that if equation is in standard form x square by a square minus y square upon b square is equals to 1, then asymptote will be b square. B square means 2 square x minus 1 whole square, b square x square minus a square y square is equals to 0. So we can write 4 times x minus 1 whole square minus 16 into y plus 2 whole square is equals to 0. Or we can taking 4 common and simplifying. So we'll be writing x minus 1 whole square minus 4 y plus 2 whole square is equals to 0. Now you can use a square minus b square, right? So we'll be writing, if I'll write a plus b, so a is this plus b is 2 into y plus 2 into a minus b is equals to 0. So what we are getting finally, we are getting two equations. One is x plus 2y plus 3 is equals to 0 from here. And from here we'll be getting x minus 2y minus 5 is equals to 0. Clear? So these two asymptote we are getting, and we know that if these two are asymptote, then the for this to be, for this point, if I'll draw from this point two tangents, then this point should always be lie in this region. Lie in this region means this one. I'll use another color. This should be my region, right? So what I'll do basically, I'll find the intersection of this line y is equals to 2 with these two asymptote. asymptote number 1 and asymptote number 2 and find out these points. So if I'm able to find these 2 points, then I can say that alpha should lie between this left side extreme point and right side extreme point, because we know beyond the asymptote line we can't draw two tangents on different branches. Okay, so yeah, now what I'll do, I'll satisfy y is equals to 2 with this asymptote. So on asymptote number 1, I am taking it as a1. So x plus 2 into 2, 4 plus 3 is equals to 0. That means x is equals to minus 7. And for asymptote 2, we'll be satisfying with y is equals to 2. So I'm writing here so that you can understand with y is equals to 2. So on second line, we'll be writing x minus 4 minus 5 is equals to 0. That means x is equals to 9. So clearly this value is minus 7, x value, y is again plus 2. Here it is 9 comma 2. These two are the point of intersection of this line with the asymptotes. So that means alpha should lie between minus 7 and 9. So minus 7 comma 9 is my answer. So alpha should lie between minus 7 comma 9. I hope you understand the concept behind this question. Okay, what we need to do, we need to first of all rearrange, write it in standard form, the equation of hyperbola. Then we have to find the asymptote, because on different branches, if we are able to find out the asymptote with the intersection of y is equals to 2 line, we'll be clearly able to see that where alpha should lie. Otherwise, beyond those two asymptote, we can't be able to draw two tangents on both the branches. Clear? So now solving next question, 68. Vertex of the parabola is given. Okay, so vertex is 1 comma minus 1, and equation of directrix is given 3x minus 4y plus 3 is equals to 0. Then length of latus rectum. Parabola is given. So why don't we do one thing? We'll try to draw standard parabola. Let's say y square is equals to 4x. So this is y square is equals to 4x. This is also a parabola. So vertex is what? 0 comma 0. Directrix is what? This is my directrix. What it is saying, we have to find a length of latus rectum, means we have to find 4a value. Right or not? We have to find the length 4a. So if I am able to find out the value of a, then easily we have to multiply it by 4. So vertex is for this standard parabola, vertex is 0 comma 0, and directrix is according to that will be x plus a is equals to 0. So now you can clearly see that this distance is actually a. So what does that mean? If I am able to find the perpendicular distance from the vertex to the directrix, which is a, then I am clearly able to find out the length of latus rectum. So here vertex is given 1 comma 1. So this is basically perpendicular distance formula from a point to the line, which I have earlier discussed. The distance was modulus of ax1 plus by1 plus c upon root over a square plus b square. So we'll find out that distance, and distance will be put it equal to a. So modulus of 3 into 1 minus 4 into minus 1 plus 3 upon root over 3 square plus minus 4 square. So that value will be 3 plus 4, 7, 7 plus 3, 10, 10 upon, this is 9 plus 16, 25, 25 root over is 5. So a we are getting is 2. But we need to find the length of latus rectum. Length of latus rectum means LLR. LLR means 4 to the 8. So 8 will be my answer. Hence option C is correct. This is the easiest question till now here. Okay. So if we know basic formula from finding the distance from a point over a line, then we can easily find out the length of lattice sector. Okay, moving on to the next question, 69. 69 is saying that that if x be a random variable of the probability distribution. Okay, so x is, let's say an event is happening where the probability of getting x is equals to 1 is 0.12, similarly 2 is 0.015, and so on. So you can see that there are only 11 outcomes, 1 to 11. So we know that the sum of the probability of all the events in an experiment should be equal to 1. So this value should be equal to 1. You can also cross check 0.12 plus 0.05 and so on. If you'll add, you will be getting is equal to 1. Clear or not? Now, for the event E, which is defined as x is an odd prime number. So if E is odd prime number, what can be the possible outcomes of the event E? E can be either, can it be 1? No, this is odd but not a prime number. So we'll start with 3 because 2 is even prime number. So 3, then 5, then 7, then 9 will not be taking because this is not a prime number. 9 is a composite number. So lastly it will be 11. Okay, so we have to find out what we have to find out. Okay, and f is also given. So f is what? X is less than equal to 6, means x can be 1, 2, 3, 4, 5 and 6 also, because equal sign is there. Now we have to find P E union F. P E union F. So means what we do, we'll taking the all the points which is in E as well as in F. So P, wait a minute. Instead of finding probability first, we'll be finding E union F. So E union F will be 1, 2, 3. All these 6 points will be taking from F, starting from 1. Now, whatever extra points are there on the event E, we'll be writing those also. So 3 and 5 we have already taken. 7 and 11 we have to also take. So this is my E union F, which is another event, and we have to find the probability of E union F. Means we have to find the probability of 1 and 2 and 3 and 4 and 5 and 6 and 7 and 11. So we have to add all the probabilities of getting these values. So probability of 1 is 0.12, probability of 2 is 0.05, 3 is 0.07, 4 is 0.1, 5 we have to take, so 0.08, 6 is 0.03, 7 is 0.2 and 11 is 0.05. So 0.05 and 0.05 is 0.1, 0.1 plus 0.1, 0.2, 0.2 plus 0.2, 0.4, 0.4 plus 11. Okay, so 40 plus 11, something like that, 51. 51 plus 19 is 70. So 0.70 will be my answer. This is one way of doing the probability. Another way is, why don't we do total probability minus remaining probability, means whatever is not in E union F, right? We can also use contradiction method. So alternate would be total minus P which not in E union F, right? So actually what is P not in E union F means E union F bar would be all those elements which does not contain these elements. So remaining elements will be 8, 9 and 10. So we'll be adding the probabilities of 8, 9 and 10 and subtracting it from total probability. Total probability is 1. Clear? So I can write Px is equals to 8, 9, 10. In that way also we can find out the answer. Okay. So this was also a very easy question. Moving on to the next question, 70. 70 is saying that the image of the line and in the plane is L2, then L2 passes through which of the following point? Okay, image of line on the in the plane P. This is same as image of a point in the line. So if you remember, image of if a point is x1 comma y1 comma z1, and if line is, or if the plane is given here x minus 4y, or let's say if the plane is ax plus by plus cz is equals to d, this is some plane P is given and some point is given, let's say point A, x1 comma y1 comma z1. Then image of point A dash will be, the formula is x minus x1 upon A is equals to y minus y1 upon b is equals to z minus z1 upon d, sorry, c is equals to minus 2 times ax1 plus by1 plus cz1 upon a square plus b square plus c square. This is the formula we are going to use. Okay. Now the thing is, point is not given. So what we have to do, from this line we have to take any random point. So for random point, what we do, we'll put the line is equals to lambda. So z plus 1 by 2 is equals to lambda. So from here we can find the general point. So the general point on this line will be, if I equate these two, we'll be getting x is equals to 2 lambda plus 1. Similarly, from these two, clearly y is equals to lambda, and z is equals to, from these two will be 2 lambda minus 1. So any random point on line L1 will be, point on L1 will be 2 lambda plus 1 comma lambda comma 2 lambda minus 1. So this is now acting as x1 y1 z1. So from this point we have to take an image in this plane, okay, which is a line L2. Okay, so what we do, we'll find first the image of this point in this plane, and then what we'll do, if we'll be able to get the image, then we with that, let's say this is my plane, this is my, wait a minute, this is my plane P, and this is some line, this is some line, let's say this is line L1. Okay, so we have to find the image of this line in this plane. So what will be the image? Image will be somewhat like this. This is my L2. Okay, so what I am taking, I am finding first of all, taking any point P, this is, sorry, A, okay, which we have found this, and then we have found the image of A in this plane P, which will be A dash. Okay, now we have found this point. Now also what we can do, if L2, okay, so what we do, first of all, we'll find out the point x minus 2 lambda plus 1 upon 1 is equals to y minus lambda upon b is minus 4. Here you can see 1 and minus 4, and z minus 2 lambda minus 1 upon 1 is equals to minus 2 times. Now putting the point on the plane. So 2 lambda plus 1 minus 4 lambda plus 2 lambda minus 1 minus 9 whole divided by a square means 1 square minus 4 square and 1 square. So 4 lambda, 2 lambda, 2 lambda cancel out. 1 and minus 1 is also cancelled out. So minus 2 into minus 9 is 18. And this is 16 plus 2, 18. So 18 by 18 is 1. So we are getting x minus times 2 lambda plus 1 is equals to y minus lambda upon minus 4 is equals to z minus times 2 lambda minus 1. So from here we got x is equals to 2 lambda plus 2, y is equals to lambda minus 4 and z is equals to 2 lambda minus 1. So this is my point A dash. A dash is 2 lambda plus 2 lambda minus 4 2 lambda minus 1. So basically what we have done is actually this is any general point on this plane A dash. Okay, so with that general point we can also form a line. Okay, so on the next page I can equate x with 2 lambda plus 2 and y with lambda minus 4 and z with 2 lambda minus 1. Okay, so from these three we'll be finding lambda in terms of x, y, z. So lambda here I am getting x minus 2 upon 2. Here we are getting y plus 4 upon 1 is my lambda, and here lambda we are getting z plus 1 by 2. So actually now we'll be able to write the image line L2. So x minus 2 by 2 is equals to y plus 4 upon 1 is equals to z plus 1 upon 2. This is my L2. Are you able to get it? Clear? So now we have to check which line, which point is passing through this line L2. So I have to randomly check. So if I'll use 7, 3, 5, first option, 7 if I'll use 7 minus 2 by 2. Now 7 and 3. Now, so it should be also 5 by 2. So if I'll use 3, 3 plus 4, 7. So first is wrong. A is wrong. Now using B, 3, 2, 4, 2. So if I'll use B, 2, if I'll put 2, 0, 4, it is 8. So B is also wrong. Now checking C, 4 minus 3, 2. If I'll put 4, 4 minus 2 by 2 means 1. Then minus 3. Minus 3 if I'll put again we are getting 1. And 2. If I'll put 2, then it will be 3 by 2. Is that a mistake we have done? Zero, 3. If I'll check D option, 0. 0 then minus 1. 3 then 7. So this is clearly wrong. C option might be correct, but maybe we have done some calculation mistake. 4. Then we are getting 1. On minus 3 we are getting 1. On 2 we are getting 3 by 2. Okay, so we have to recheck that where we have done mistake. 2 lambda minus 1. X and y is correct now. So 2 lambda plus 1, this is lambda, this is 2 lambda minus 1. Wait a minute, guys. Okay, guys, I'll let you know in the next session. Okay, time is about to end, so we'll end the session right now. I'll get back to you on this in the next session. Till then, keep learning and keep solving the doubts. Okay. Hope for the best in the next mock test. Okay. Okay then. Goodbye.